Welcome back. We're still working on 600 Club Worksheet 2. So let's keep going. Number 6 says y is equal to ax plus b and also y is equal to negative bx. The equation of these two lines are shown where a and b are constants if the two lines intersect. So this is like we talked about a minute ago. We actually know they intersect at a single point, 2 and 8. So what does this mean? This literally means that when x is 2 and y is 8, that it is true in both equations. So when x is 2 and y is 8, that it's a true circumstance in both equations. So let's take a look at that. We have 8 is equal to 2a plus b, and we know 8 is equal to negative 2b. So do we have a way of figuring out the value of a? So we're really close in this equation to figuring out what b is. So let's go ahead and finish that out. If 8 is equal to negative 2b, and we divide both sides by a negative 2, we get b is equal to negative 4. Now we can substitute it into the other equation. So 8 is equal to 2a plus a negative 4. So to solve for a, let's get a by himself on one side. We get 12 is equal to 2a. So if we divide by 2 on both sides, a is equal to 6. That's one of our answers. Cool. All right, so let's keep going. They get a little harder. It's just as you go along, they get a little more tricky. This one's more work just because they wiggled some things around, but let's keep going. I almost have y by itself. I got y is equal to negative 5x, and if I subtracted 2 on both sides, minus 2. So let's substitute that in here and see what we get. We also need to distribute this as well. So 4x minus 2 is equal to 3 minus 3, and I can substitute this in for y. So let's distribute. So 4x minus 2 is equal to 3 plus 15x plus 6. All right, let's combine some like terms here. So we get 9 plus 15x. All right, still working to get x by himself on one side. So it looks like I get x is equal to negative 1. Well, I can stop because there's only one choice where x is negative 1. Here we go. How many solutions does this system have? Very interesting. So what does that mean, and what would it look like if it had more solutions? So if I use this as another example, if I had a line, let's say, that was here, notice it would go through there twice, and so there would be 2 coordinates of x and y where that would meet. So let's just use the same technique we've been using and try to solve. Now, this one's set up for cancellation really good. We can multiply everything on the left and right by negative 2. That way this would cancel. So let's rewrite the top equation and then rewrite the bottom if we distribute the negative 2. So I get a negative 2x minus 4y is equal to a negative 8. Okay, so 2x minus 2x would be 0. Negative 4y minus another 4y would be a negative 8y. And 8 minus 8 is 0. So if I divide negative 8 on both sides, y is equal to 0. Now, don't be fearful of this y equals 0. There's nothing wrong with that. We can have this coordinate right here is the coordinate, this coordinate right here is the coordinate, looks like 3, 0. So just having a coordinate of 0 shouldn't be that scary. Now let's plug 0 in for y and see what x ends up being. So my original equation, x plus 2, and if I make y 0, has to equal 4. So I have x plus 0 equals 4, so x is equal to 4. So I end up getting one answer, and the system equation, they meet at the coordinate 4, 0. So that would be on your coordinate plane at 4, 0. So it's very obvious that 2 lines could meet at that coordinate. One with a positive slope or a negative slope, they can meet at that coordinate. But I do know that this problem, because I worked with a few students, throws you off because you ended up getting a 0 for one of the answers. 10, in a system equation above, if this has infinitely many solutions, what would A be? So again, let's explain what that means. So let's say I have an equation, let's use a fairly basic equation. Let's say the intercept here is 2, and it has a slope up 4 over 3. Okay, so 4/3 x plus 2. Okay? Now, if you look at this equation, you're saying, could it look like this? Well, the answer is yes. If I multiply everything by 3, then I get 3y is equal to, that would get 4x plus 6. So notice this is exactly how these equations look. So how could we figure out what it would mean for one equation to have an infinitely many intercept this line that I've graphed, just an example graph, an infinite number of times? Well, the way that would happen would be if it was the same graph or if it was right on top of it. So that's exactly what would happen here. If you typed this into Desmos and you typed this into Desmos, they would graph right on top of each other. So every value for x that is a solution for that line will give you the same value of line, whether you use either equation. The only difference was I multiplied 3 by every number in the equation. So it's exactly the same equation, it just looks different to students. It looks different, but to a graphing calculator, it's exactly the same equation. So let's take a look at that. The way we'd want to compare is looking here, if we got the same thing for each term. So I can do that if I can multiply everything by -2 on the top. And again, it's an equation, so what I do to one side of the equation, I got to do to both sides. So let's see what happens when I multiply a -2 on both sides. I get a -4x for the first term, a positive 10y for the second, and a -2a for this last term. Now let's compare it with the second expression, which we know has to be the identical equation. So notice these line up, these are identical. How would we make these identical? Well, we would need b to equal -4. How would we make these terms identical? We would need -8 to equal -2a. Well, they didn't ask what the value of b is, but if they did, it would be -4. So this is to kind of throw you off. What would a be? So if I divide both sides by -2, a is equal to 4, and that's my answer. Okay, one last question, 11. It didn't fit on here, so I had to write it on with my own handwriting, but it is the same question out of this book. In the system equation above, a is constant. If the system has only one solution, which of the following cannot be a value of a? Okay. So we see here, if the two equations are the same, they have infinite number of solutions. Here they said if it has one solution, which can't be the value. So I think the fastest thing to do is to just plug these in and see what happens. So let's start with this first one. What if a is a -1? So let's try that. It says -1 times x plus 2y is equal to 5. So we're comparing these here, and let's just solve it the way we would normally solve it. All right. If I multiplied, kind of like I did this last time, everything by a -3, I would get, and again, just rewriting this, -3 times -1, I get a 3x, -3 times a positive 2, -6y, and I get a -15. On the bottom, I can compare 3x minus 6y equals 20. So now you should be noticing a falsehood. something fishy happened because these equations are the same. The only thing I did to the top equation is multiply everything by a -3. So that shouldn't change the equation. But notice now what's happened. It's saying 3x minus 6y is equal to -15, and 3x minus 6y is equal to the number 20. That can't happen. This expression can't be these two numbers at the same time. So that's exactly what I was looking for, is if I know that this should be able to solve out like all these other questions solved out, this one can't be solved out. So in fact, if you plug in 1 for A, or 3/4 for A, or 3 for A, you will get one solution. Now, it'll be an ugly fraction for all of them, but you will get one solution, meaning you'll get one value for X and one value for Y. Here, no matter what I do, I can't get a solution because of this situation that's happening. Thanks for joining us. Keep up the practice.